Okay, so we have a problem where hypothetically a bunch of data points, and we got a curve that fits those data points, okay? Now, there are electronic ways you can get the curve. You can also sketch and try to get your curve as close as possible on the average to the points while maintaining the smooth shape of the curve. We have natural log of y equals 1.7x plus 3. Now, we would do with this data, okay, if you have your data, you know, you would have an XY table. Okay, you'd have numbers in here. Do what we did last time, you do x and natural log of y. What's the natural log of y versus x? Okay, so what would happen with this data is if you plot natural log of y versus x, you're going to get a straight line. Okay, or you're going to get a bunch of points. And it's going to straighten out this set of points. So you look at this graph and you find its slope. Okay, so you might find a slope of 1.7, y-intercept of 3. Now that doesn't look like a y-intercept of 3. It's too low, right? That's a negative. So, I could kind of fix it. Although if you did that for the points that I've marked here, you would get some negatives. But what I can do is I can just kind of move the x-axis, make it more realistic. And you might have some points down here below the x-axis, because the natural log of y can be negative. It's negative between here and here, right? Okay. So anyhow, if you did this, and you could do this, if I gave you 20 data points, you could put them into Excel, get a y versus x. Then you could do natural log of y versus x. Excel does a natural log. I think in Excel, natural log is log, which is really base 10 log. Okay. But it would work fine with a base 10 log too. You just have to use, well, don't worry too much about that. Okay, the process is, if you had these data points, you put them in Excel and you could then do a column of natural log of y versus x and create the graph. Excel does all that and ask Excel, what's this equation in the straight line? Okay. Excel is going to tell you, and maybe Excel fits this out. Maybe it's just a few data points like it was at the end of class last time, okay? And there were only 3 or 4 data points. And we did all that. Make a table of y versus x. And we did log of y versus x. We got a line and we did all this. Okay, so anyhow, at this point, we're here. Okay. So we want to solve for y. How do we solve for y? Write down the right letters. Okay. So in this equation, I wrote that. I'm not sure what I was thinking when I wrote that. That's the correct equation. I think I'm logging it now, sorry. Okay. So we identify B. Okay, well, using this, we can rewrite the equation in the form log base B. Because natural log is log base E, not base B. We can then change this to exponential form. Now you got to remember that the natural log is the base E log. Okay. If you're going to use this format, you got to know what base to put in there. And an log with nothing, with no base, is a log base 10. Okay. Okay. Now that we've got this written in this form, we can see what B is. G equals E. C equals 1.7x plus 3. And A equals what's wrong with my visual perception here, but A is, we have this form. B is E. A is 1.7x plus 4, because it's log base E of y equals this. And A equals B. C. Okay, A, B, C, D, E, F, G. Okay, I think I've got the alphabet. Sorry. Let me write that more coherently. Can't say it a little more coherently. Okay, this matches this if B equals E. C is what's in parentheses. S C equals Y. And A is on the other side of the equal sign. A equals 1.7x plus 3. So B to the A equals C says E to the 1.7x plus 3 equals Y. Okay. So there it is. Okay, so but that's not in the form A B to the X. Okay. To get the form Y equals A B to the X, we use the rules of exponents. Y equals E to the 1.7x multiplied by E to the third. E to the 1.7x. It's not space. Well, let me try that again. Okay, well, E to the third is around 16. And then it's 16 E to the 1.7x. Okay, well, that's still not in form A, B to the X, because your exponent should just be x, and here the exponent is 1.7x. Okay, well, let me write those steps down here. Y equals e 1.7x plus 3. Y equals e to the third times e to the 1.7x. So y equals approximately 16. Now e to the 1.7x is e to the 1.7 raised to the x power. Now I can't tell you exactly what e to the 1.7 is, but I think it's in the upper fours near 5. Maybe it's 4 point something, but I could be pretty far off on that, okay? E to the 1 is just like 2.7, okay? E squared actually is 7.3 or something like that. So let me interpolate between there and there, and it's concave up. So I'm gonna say it's about 16 e to the 16 times 5 to the x, okay? I think one person got a result, and I think that result was 20 e to the 5.47x, okay? A little rounding off there, we get this. If you use your calculator, you can get e to the third to 48 decimal places, which would be ridiculous, okay? And you could get e to the 1.7, an equal number of decimal places. It's gonna come out, I think, kind of close to that. This wasn't a bad estimate, considering these things are kind of hard to estimate, okay? And considering I didn't try that hard, but still wouldn't have been that great, okay? And I think that's an accurate calculator result to two significant figures on each number. Okay, well, that's the process. Now, let me point out two things on the homework. Some people have right answers that open math just didn't accept. Because open math had about this many decimal places, and you only use 6. Well, 6 decimal places is plenty, okay? You match open math's ridiculous result, okay? And I don't blame that on open math. You know, people write these things, so whoever wrote it might have been in a hurry and got careless, and then never went back and fixed it, because they're busy too, okay? That's why I go through the homework and make sure that, you know, your results make sense. Because I looked at the numbers, I go, those numbers seem reasonable. Let's check what the real answer is. And just one click, I get the real answer. Well, that matches all the way up to the 6 decimal place, okay? 6 significant figures, and open math didn't give you credit for it. Okay, well, again, that's not the fault of open math. That's a fact that these things can be written by anybody. And remember, I'm the one that chose the problem. Okay, out of a big bang. Other thing, now this is the process you should have used on several of the problems. Okay. Now, the fact that you weren't able to get every detail of it, although some of you got quite a bit of it, tells me you can be learning more when you do your homework. Okay. Remember, these sets stay open for practice. And just remember what I've said about the way you do the homework. Try to do as many problems as you can without any reference, other than what you've learned in previous problems, okay? That's how you build understanding. Still kind of tough. This isn't the easiest thing in the world, okay? But make sure you're spending enough time on it. If that time is available. Okay. We're going to move on to something simpler. And that's kind of the end of what we're going to do with exponential and logarithmic functions. Okay. So let's start something different. Not really that different because you did it. I think I might have done some of this. We might have done some of this in class once. I'm just going to give you. Okay, now what did I use? Okay, I think that will work out. I'll double check it. But we're going to solve this by elimination. So see what you can do. We'll write these questions. You had any of this in class last time? We did one like this? Okay, that would have been in the support course. Good, thought we were pretty well. Yeah, last thing we did was just basically what we did here. Okay. Well, yeah, I think that works. Okay, now people that aren't in the support course where we've been doing this anticipate are having a little trouble remembering what to do. Okay, because it's been 2 months since we did this in chapter 2 with straight lines. Okay, first place, you remember graphing these things and seeing where the graphs intersect? Now, if the only place you did that was on open math, moving lines around with your mouse, okay, you're not going to retain it. You're not going to be retaining it as well as you would if you draw these by hand and calculated all the intercepts and everything, okay? So we'll do that, but we're going to solve this by elimination, okay? We're going to call this equation 1 and equation 2. So I'm going to ask you to do what I say. I'm going to ask you to multiply equation 1 by 2, multiply all the numbers by 2. In other words, multiply both sides of this equation by 2. That's what I mean by 2 times circle 1. Remember doing this? That seem familiar? Vaguely. So you got a few neurons that are firing. They'll all fire in a minute. Okay, and then write down equation 2. So 2 times equation 1 goes here, equation 2 goes here. Make sure everybody's on track. Go ahead and tune in to what I'm doing here. Okay. Off to the side, you can do 2 times equation 1. Okay. So off to the side, I'm going to write two times equation 1. So I'm going to take equation 1. And I'm gonna multiply 2 by this side, and I'm gonna multiply 2 by this side, which is gonna give me 8x plus 6y equals 36. That clear? That's what we mean by multiply equation 1 by 2, because I think some people are having trouble interpreting what I meant by that. It said multiply both sides, but it didn't write it out, okay? So now, once you see this, you don't really need to write it off to the side. You can pretty much just do it in your head. But if you need to do some of these calculations, don't do them here. Leave this area right here. We're going to keep the equal signs lined up. We're going to keep the y's lined up. We're going to keep the x's lined up, okay? So do side calculations to the side. But when you do 2 times equation 1, you get 8x plus 3y plus 6y equals 36. And down here, you get 7x minus 6y equals 9. Okay? Now we add these 2 equations. I'm going to say 1 plus 2, meaning equation 1 from the previous step added to equation 2 from the previous step. And that's going to give us, well, 8x and 7x gives us 15x. And we get no y because 6y minus 6y is 0 equals 45. And we quickly solve that. And we get x equals 3. Now, what do we do with that x equals 3? See if you remember. I'm only going to give you a minute or so before I refresh your memory. Okay, I think things are coming back to people who haven't done this for a couple of months. Of course, people who've been doing this in the support course are kind of bored right now, but let's see if we can take care of that. Okay. So we have x equals 3. Well, I'll write it schematically like this. I just say, okay, x equals 3. We're going to take that 3 and we're going to plug it in for x in the first equation. That's going to come down here and give us the equation 4 times 3 plus 3y equals 18. Well, that equation is real easy to solve. I don't think anybody's going to have any trouble solving it. Yeah, you multiply the 4 by the 3, you get 12 plus 3y equals 18. And you know what to do from there. I'm not going to take time to write it out. You get y equals 2. Okay. So you solve this equation. First thing you do is multiply 4 by 3, and then you should be in familiar ground. Subtract 12 from both sides. You get y equals 2. Okay, and I'm just going to refresh you. Let's make sure you know this. This is the kind of question I'm going to ask you. Okay, I'm going to ask you to slap these 2 equations and validate your solution. Okay. So we plot the equations of the x-intercepts. Now, if I'm going too fast for you, go back to the MDE 61 and look at what we did. I think it was last class, okay? Because I went over it in more detail then. But I don't think you really need all that detail if you remember to do what I'm saying, which is make sure you know how to find the intercepts. So you remember that the x-intercept occurs when y equals 0, y-intercept when x equals 0, right? So I'm going to write that down, but I'm not going to do any more with it. I'm just going to say what they are. So if y equals 0 here, we have 8x equals 36, which means the x-intercept is right here on the line where x equals 4.5. And if x equals 0, we're going to get 6y equals 36. We're going to y equals 6. And these will be the intercepts. And the graph will look something like this. And we label this graph 8x plus 6, but we label the line 8x plus 6x equals 8x plus 6y equals 36. Okay. Then we find the intercepts of this equation. Okay. Well, if y equals 0, we get 7x equals 9. So x would be 9/7. Now 9/7 is just a little more than 1. And if this is 4.5, then there's x equals 9/7. And we're going to have this point. If x equals 0, negative 6y equals 9. So y is negative 3/2. Now, where's negative 3/2? That's negative 1.5. 1.5 is 1/4 of 6. If we were to divide this in half and then divide this in half, that would give us something like 3/2. Of course, we've got to go negative 3/2. So we use a little common sense and we locate y equals negative 3/2. And right here is the y-intercept of this line. Now, these points are pretty close together. So if I'm off by just a little bit and where one of those points is, it's going to throw the slope of this line all the heck. Okay? So it's going to be kind of hard to get the exact solution. X equals 2, x equals 3, y equals 2. But at least the solution should be in the vicinity of x equals 3 and y equals 2. Okay? So we sketch a line. I didn't intentionally go through this point, but let's see, it's actually 4.5 is y equals 6. I'll give you about 31 and 6. That's pretty well. Yes, that look wrong with my calculations. Anyhow, there's our point of intersection. Okay. I wrote this kind of small. I say, is this consistent with x equals 3 and y equals 2? Well, it's consistent, but it's not all that close. Still, given the uncertainties in locating these 2 points on a hand sketch graph, where this slope might be really screwed up, it's not going to be too bad. So where's y equals 2? Well, y equals 6 is here. If we go twice as close to the x-axis, pretty much look like we got y equals 2 at this point, not, sorry, y equals 3 at this point, not 2. Also 4.5. Well, if this is 4.5, there are 2 ways to look at it. A third of this ought to be 1.5, so 2/3 of it ought to be 3. That puts 3 out about here. We could say if that's 4.5, then 4 is pretty close to 4. We divide that in half, we get x equals 2. So x equals 3 should be over here somewhere. So the point, and where's y equals 2? Y equals 2 is about here. So the point where x equals 3 and y equals 2 is here. Okay, the points aren't the same. This one looks like about 2.5, 3 or something like that. But they aren't that far apart. And remember what I said about these 2 points. If this point should have been a little further to the right, and I put that down pretty carelessly. And if this point should have been just a little higher, the line might well have gone through this point, right? Okay. So notice that this point is close to this graph because I used this graph to determine where x equals 4.5 was and y equals 6. And I just declared here's 4.5, here's 6. So this line should be pretty accurate. So the point is pretty close to the line on this line, right? Okay, but it's kind of far from this line. So I would say that our conclusion is this consistent with x equals 3, y equals 2? I'll say it's not great. But probably okay. And there's our conclusion. Now, of course, if we want to determine whether our solution is accurate, graph is helpful. It's instructive, gives you a little practice making linear graphs, which is an important skill. Okay. But we just plug these numbers in to the equations. Plug 3 and 2 into the first equation. 4 times 3 is 12. 3 times 2 is 6. 12 and 6 is 18. Same thing up here. 7 times 3 is 21. 6 times 2 is 12. 21 minus 12 is 9. So it does check. Okay. So in a sense, this step is unnecessary if you know how to do the check. If the arithmetic works out, then you've got it right. On the other hand, this gives you a picture of what it means. Okay. And it also gives you a third check, because if you draw these things and the point that you get from the equations is here, but your solution to the equations is up here somewhere, then either you screwed up the graph or you screwed up your arithmetic. Okay. Now, if your arithmetic checks out when you check it, then you probably screwed up your graph and you learned something about how to fix a graph. Okay. Either way, you learned something. So that's a procedure I would recommend that you master. Okay. Now, again, this is a review of what we did in chapter 2. I think it's coming back to everybody. So I'm not going to talk too much about 2 equations and 2 unknowns, although the only assignment I'm going to give you, and let me double check and make sure. Okay. Okay, hang on a minute. Okay, so let's see, I'm getting. Okay. And then okay, I think that's good. Okay, so I've got equation one, equation two, and equation three. I'm not gonna write anything underneath this until I've done these calculations, okay? I'm gonna write two equations under here. I'm gonna write equation two plus 3 times equation one. And equation three minus 2 times equation one. Okay. Now, you're probably going to calculate some of this off to the side. Okay, so I'm going to recommend that you write this 2 plus 3 times 1. And then down here, write equation 3 minus 2 times equation 1. And use this space to work out 2 times plus 3 times equation 1. Use this space to work out 3 minus 2 times equation 1. Okay? So just start with this. Don't even write this down yet. After you get this done, then you'll know where to write this one. Okay? See if you can do equation 2 plus 3 times equation 1. What you want to do, I'll even give you another hint. I want you to write down equation 2. And then I want you to write down 3 times equation 1. And then I want you to add them. Okay? So here you write down equation 2. That's easy. There it is. Write it down. Okay? And then 3 times equation 1. Well, I think from what we did a few minutes ago, you know what to do with that. So I'll look over your shoulder, make sure you're on track, and give you a hint if you need it. Okay? Okay. So people are working ahead a little bit because everybody did real well on this. But okay, we do 2 times plus 3 times 1. Okay, well, equation 2 is here. Just write it out. And equation 3 is here. We're going to multiply both sides of equation. Sorry, equation 1 is here. We're going to multiply both sides of equation 1 by 3. Well, 3 times 3 is 9. 3 times -2 is -6. 3 times 8 is 24. 3 times 12 is 36. And those are the numbers we're going to get. We'll multiply that equation by 3. We're going to get 9x minus 6y plus 24z equals 36. And I hope I'm doing this right. Okay. And why did we do this? Well, implicitly, I've chosen to eliminate y. If we look at the original systems, we see that all these numbers are multiples of 2. All these numbers are multiples of 2 as well. So we could have done similarly with z, but the numbers are smaller on y. So we made that choice. This gives us 13x plus 12z equals 38. Well, now that we've figured that out, why don't we go ahead and write it down? We put 13x here. I'm going to keep my x's, y's, and z's lined up. There's no y here because 6y minus 6y is 0. We didn't have to write that. So the 12z, I'm going to want to put over here. Keep things nice and lined up, which is kind of nice in itself, but it's going to be important for what we do next. Okay, so this is going to be 36. Okay, then 3 minus 2 times 1. That means equation 3 minus 2 times equation 1. Okay, so equation 3, we write out 7x minus 4y plus 10z equals 20. And then 2 times equation 1, but minus 2 times equation 1. So minus 2 on the left side is going to give us negative 6 plus 4, negative 16. On the right, it's going to give us negative 24. So we're going to have minus 6x plus 4y minus 16z equals negative 24. We add these, and the y's are again going to go away. So we've got x minus 6z equals negative 4. And we write that over here. And let me just check and make sure that's on track. Yep, that is. Okay, now let's see what we've got. We've got a system of 2 equations and 2 unknowns. So we proceed to solve that. I'm going to go ahead. That's what everybody's been working on while I was talking about this. And hopefully everybody's got a good solution. Well, I look over here, it's going to be easy to eliminate z, right? Just double this and add to this and z goes away. Now I can't just double this. I've got to double the whole equation. In other words, multiply the equation by 2. And if I need to write that off to the side, I will. We want to keep the flow of the solution going right here with the side calculation somewhere else, okay? So what we're going to do is we're going to do equation 1 plus 2 times equation 2. Where equation 2 means this equation 2, not this equation 2. This number always refers back to the last set of equations. Okay, so we're going to have 13x plus 12z equals 36. And let me write that a little differently. This is an option for how to do it. Equation 1 here, 2 times equation 2 here. There's my 2x minus 12z equals negative 8. Now I add something wrong. This equation will correct. Something is wrong. Negative 4 there. Yeah, it has to be right. What I'm getting here is 15x equals 28. Should be 15x equals 30. Okay, that's 4 minus, well, it's negative 8. 26 plus 38. Oh, look what I did. I copied down the 36 here, which is right next to the 38, which is what I should have copied down. See why it's important to keep this stuff nice and organized so you can spot those things? Okay. Now, I didn't do that intentionally. I did it by mistake. But you see that the organization, shaky as it might be, help me locate my error. That's 38. This is 38. Now there's 30, so x equals 2. Okay, well, let's cut out of time. Let's quickly, we plug x equals 2 back into one of these 2 equations and solve for z, right? Then we got X and Z, which we can solve, plug into one of the first three equations and solve. Now, out of time, took a little longer to do that. But Open Math is going to show you those details. And I think most of you are pretty good with that, okay? I don't think you'll have any serious problems. Okay. So systems of two equations and systems of three equations will be due Tuesday. Okay, next class. Fair enough? Y'all did real well. I don't think you're gonna have much trouble with this assignment at all.